Bismillahirrahmanirrahim. My name is Dr. Muhammad Iqbal, and the topic of my presentation today in this conference is enhanced nickel removal with white willow from contaminated soil under the influence of PGPR. So I am Associate Professor in the Department of Environmental Sciences and Engineering, Government College, University, Faisalabad, Pakistan. Outlines. Introduction. Sources of soil pollution with nickel. There are different sources of soil pollution with nickel, effluents from different industries, industrial solid waste, coal fly ash, mining and smelting. So these are the different sources from where the soil is polluted with nickel. So hazards of nickel polluted soils to the environment: food contamination, they reduce crop yield, pollution of water bodies due to runoff, groundwater pollution, effect on soil fertility, effect on soil organisms. There are different remediation strategies for the remediation of nickel polluted soils. For example, soil excavation, soil replacement, solidification, vitrification, and washing. These treatments are harsh. They have more demerits and less benefits. They are costly, laborious, less acceptable by public, and they damage to the environment. Phytoextraction is a gentle remediation strategy that has more benefits and very less detrimental effects on the environment. Phytoextraction is the process of extracting heavy metals such as nickel, lead, cadmium, copper from the soil by different cumulative plants or high biomass producing plants. The positive effect of phytoextraction of the soil is increased fertility, increased water holding capacity, increased removal of metals from the soil, reduce metal from the soil, and decrease nickel's toxicity to the plants. So what are the processes that happen during nickel phytoextractions? There are certain microbes that solubilize nickel in the soil, reduce nickel stress to the plants, enhance soil enzymes, and there are many different organic amendments that provide nutrients to the plants during phytoextraction and improve soil health. Problem statement. Nickel contaminated soil can contaminate groundwater, agricultural land, and water bodies. Thus, remediation of these soils is needed. Objective. The objective of our research is to investigate the role of rhizosphere acidifying plant growth promoting rhizobacteria for reducing soil pH, exclusive in the rhizosphere of Salix alba, which is called white willow. The effect of reduced soil pH on the viability and phytoextraction of nickel from the soil. Biostimulating role of LM and AM. These are two organic amendments for enhancing the efficacy of nickel phytoextraction by Salix alba from nickel polluted soil formerly receiving nickel rich effluents from electroplating industry. Here LM is the organic compost prepared from green waste, and AM is the organic manure of cows, while the LM is the compost of kitchen waste. So the post experiment contained 6 treatments: control, B, LM, B plus LM, A, B plus AM. Here the B is bacteria that is going to acidify the rhizosphere of Salix. Nutrient sources are cow dung, which is called AM, kitchen compost LM. Pot size was 3 kg per pot size, the soil. Nickel contamination was 72 milligram per kg soil. Duration was 3 months. Plant name was Salix alba white willow. Materials and methods. Soil analysis. The soil analysis was conducted through standard protocols. For example, variable nickel in the soil was measured by DTP extract, pH with pH meter, cation exchange capacity by Rodas method. Soil texture was assessed by hydromethyl method. Soil enzymes, dehydrogenase, beta glucosidase, urease, acid phosphatase, and peroxidase were measured with the method explained in IBBC-2023 2022. Bacterial count, microbial biomass, and organic carbon in the soil were done through various methods explained in IQBAL 2022. Plant analysis, nickel concentration in and the content in shoots and roots was measured by using various standard protocols presented in IBBC-2023 2022. Chlorophyll A and B in the plants were measured by using spectrophotometer. Results and discussion. Here we can see that soil pH. Soil pH, here we can see that the soil pH of the rhizosphere was relatively lower compared to the bulk soil. So rhizosphere is the zone that surrounds the plant roots. It's the most active zone where the microbes live and they perform their functions. In this figure 1, we can see that inoculation of bacteria has significant effect on reducing soil pH compared to control. So AM and LM, they did not change soil pH. But when LM plus bacteria was together applied in the soil, their effect was the highest for decreasing soil pH. Distribution of nickel in salix plant parts, values of BCF, bioconcentration factor, and translocation factor of nickel, valuable nickel in the soil, and nickel removal from soil as factored by adding LM, AM, and Bacillus species. Here we can see that the highest concentration of nickel in shoots, roots, nickel contents in shoots, roots were the highest in B plus LN treatment. Similarly, bioconcentration factor, translocation factor of nickel removed from the soil, as well as TTB extractable nickel were the highest in the same treatment. Nickel distribution in plant parts and soil enzymes. After the nickel distribution in plant parts, we can see that the activities of soil enzymes, as well as the bacterial count, microbial biomass, and organic carbon, they all were the highest in bacteria plus LM treatment. Conclusions. Bacteria acidified the bulk and rhizosphere soil more than LM alone inoculum. The highest nickel solubility was observed in B plus LM treatment, leading to the greatest nickel concentrations, contents, and nickel removal values. The highest soil enzymatic activities, microbial and bacterial biomass, organic carbon were found in B plus LM treatment. The B plus LM treatment can efficiently clean soil from nickel pollution and improve soil enzymatic activities. Thank you very much for hearing my presentation.